Okay, today I'm going to talk to you about percentage yield calculations. So we're going to look at what percentage yield actually means, and then we're going to complete a calculation to show how that works. So yield just means the amount of product produced. Now let's just imagine this. Let's imagine in a lab we were doing a series of reactions between some reactants to make a product. Now let's imagine this. If I have 40 grams of this and I had 10 grams of this, my theoretical yield would obviously be 50 grams. I'd expect to be making 50 grams of this. However, in reality, this is never the case. Now, the reason for that is, well, there's three different reasons. First of all, we could have loss of material. So it depends upon what we needed to do to mix our reactants together. If we're transferring liquids from one container to another, some of those liquids could be left on the inside of the container. Also, if we were evaporating, some bits could just kind of spill out when the evaporation was happening. So we could lose some material, which means this number would go down a bit. We could also have unwanted reactions. Now what that means is there could be some kind of impurities that our reactants react with, meaning we don't get our desired product or that much of our desired product. And also we could have incomplete reactions, meaning that not all of our reactant ended up reacting. So in reality, we never actually get our theoretical yield. We always get less. So let's say in this particular example, we got 45 grams opposed to 50 grams. Now, to find our percentage yield, what we need to do is find our actual yield, what we actually got in our experiment, divide it by our theoretical yield, so what should we have theoretically got, and then we just multiply that answer by 100. So 45 divided by 50 multiplied by 100. This particular experiment will have a 90% yield. Now what that means is 90% of the mass of the reactants has ended up in our desired product. Okay? So obviously the higher the percentage yield, the better, because it means there's less waste. So it's good in terms of economically, the higher this is. If we've got 100% yield, it means we've got absolutely none of this going on. If we have a 0% yield, it means none of our reactants has ended up in our products. So let's see how to complete a calculation. So here's a typical kind of question you could be asked about this. It says this: in an industrial reaction, 12 kilograms of zinc was extracted from 50 kilograms of zinc oxide. Calculate the percentage yield. So if I look carefully here, I can see I started off with 50 kilograms of this and I've made 12 kilograms of this. So what I need to do first of all is I need to figure out kind of my theoretical yield. So if this was the absolute perfect situation, how much zinc would I have made from 50 kilograms of zinc oxide? So my first step, what I need to do is I need to find my relative formula mass. So for zinc is just here. So zinc is 65. Oxygen is just here, which is 16. So add them together, 65 plus 16 is 81. And on this side, my zinc, I've just looked it up, that's 65. Okay, my next step, because I need to factor in my mass, I'm just going to convert these from kilograms to grams, because I need them to be in grams in order to use an equation triangle that I'll show you in a second. So 50 times 1,000 equals 50,000 grams. And on this side, let me see, 12 times 1,000 equals 12,000 grams. Now, what my next step is, this shows me what I actually found in this experiment, but I need to find how much would I theoretically get. So in order to do that, what I first need to do is I need to use this equation triangle that I'm going to show you right now. Okay, so we have M, which stands for mass. We have N, which stands for number of moles. And we have MR, which stands for relative formula mass. Now this could be a relative formula mass if we're talking about a molecule, or relative atomic mass if we're just talking about an atom like that. So what we need to do first of all is find the number of moles of zinc oxide which reacted. So to find the number of moles, we just cover up that little n, and we need to do mass divided by the relative formula mass. So my mass is just here, 50,000, and divide it by my relative formula mass, which is 81. Now, I need to do that on my calculator, obviously. 50,000 divided by 81 equals that number there. It's a really long number. Now, don't be afraid if we've got, or don't be worried if we've got numbers like that. They are expected. So, I'm going to write this down and simplify it for now, but I'm going to leave that number in my calculator because I'm not going to round it too early. Okay, so I now know the number of moles of zinc oxide that's reacting. Now, if I know the number of moles of this, I can figure out the number of moles of this by looking at this thing called the molar ratio. How many molecules of this react in order to make how many molecules of this? So I can see by looking at my symbol equation, I have a ratio that shows that for every 2 molecules of zinc oxide, 2 molecules of zinc are produced. Now, a simplified way of writing that ratio is just 1 to 1. Now, what that means is if I have 1 molecule of this, it will form 1 atom of this. It also means if I have 617.28 moles of this, it will produce, because it's 1 to 1, it will produce the exact same number of these atoms. So the number of moles is going to be exactly the same for here because it's a 1 to 1 ratio. So my number of moles is 617.28. Right. What I'm now going to do is I'm going to figure out my theoretical yield. Remember, what that means is in a perfect world, if this reaction was perfect, what mass of zinc would I produce? So to find my mass, what I'm going to do is I'm going to cover that up, and I'm going to do my number of moles, which is this here, multiplied by my relative formula mass, which is here. Okay, so let's do that. Now I've left that number in there, and then I'm going to multiply that by 65, which equals 40,123.46 grams. Okay. Now, remember what this means is in an ideal world, that is how much zinc we should theoretically produce. But in reality, we produced a lot less. So what I'm going to do is I'm just going to save this number into my memory on my calculator. So I can use it in a second because my final step is I need to find the percentage yield. So what I do is I take my actual yield, what it actually found in the experiment, 12,000 grams. I'm going to divide it by my theoretical yield of 40,000 or 40,123.46. And then to express it as a percent, I'm going to times by 100. So let's just do that. 12,000 divided by then the answer that I got previously. So I'm using that answer button so I can use the exact number, which equals 0.299. But then I need to multiply it by 100. So in this case, my percentage yield is 29.91%. This isn't very good. This is very low, which means it's quite wasteful. This is going to cost me a lot of money because some of these things must have happened. I must have lost some material on the way, or there's been unwanted reactions, or there's been incomplete reactions, or all three. So that is how we complete percentage yield calculations. Thank you.